our volume of pyramids. So previously we went over volume of prisms and volume of cylinders. Next is volume of pyramids. So we're going in kind of the same order as how we did surface area. So when we started surface area, we started with prisms, then cylinders, then pyramids, then cones. So today we're going to do volume of pyramids. Shh. We're quiet now and you're paying attention. So the formula for the volume of a pyramid is V is equal to 1/3 capital B times H. Now that capital B value is that base of your pyramid. So it's usually that bottom regular polygon. Okay, so in this one, that would be right here. Okay, so that square or rectangle. Okay, your height is the distance from that vertex point to the base. Okay, so right here would be your height, and it does need to be perpendicular to that base. Okay, so capital B is the area of the base, just like it has been for everything else we've done. Okay, so capital B is the area of the base, and H is the height of the pyramid. Okay, so we need the area of the base and the height of the pyramid, and we can find the volume of each pyramid then. Okay, so going over an example, number 1, we need to find B and H in order to find V. Okay, so to find B, since my base is right here, okay, so that bottom rectangle, that's your base. We need the area of that base. Since it's a rectangle, we can multiply base times height of just that rectangle. Okay, so that would be 9.5 times 8. Okay, of just that rectangle. Those are my 2 dimensions there. Okay, when I multiply those together, we get 76. Okay, so my capital B value here will be 76 centimeters squared. Next, I need the height of the pyramid. Again, that's that distance from the vertex to the base. Okay, so that would be this length right here. Okay, that's 9 centimeters. So now that I have B and H, I can find the volume. Okay, it is 1/3. Capital B is 76 times H is 9. Okay, if you don't like the 1/3 fraction there, you can multiply 76 and 9 together and then divide that number by 3. It's the same thing. Okay, and that will give you 228. Okay, so our volume here will be 228 centimeters cubed. Okay, and again, volume is in cubic units. Okay, questions on how I did number 1? All right, then looking at number 2. Number 2 is a little bit different. What is your base in the shape of? A triangle. Okay, so your base is this shape right here. And it is a right triangle. So to find capital B, I need to use the area formula for a triangle instead of just base times height. Okay, so to find capital B, we're going to use base times height divided by 2, since this is a triangle. Okay, so we're using that triangle area formula. Now the base of your triangle is 15. What's the height of that triangle? Height of the triangle? 6. Okay, so I need to use just the dimensions of that triangle, not the entire pyramid. Okay, so I have 15 times 6 divided by 2. That is 45. So my capital B value will be 45 feet squared. Okay, then what's the height of this pyramid? 14. Okay, and again, that height is the distance from the vertex and perpendicular to your base. Okay, so that's where I'm getting that 14 from. So now that I have capital B and H, I can find the volume. Okay, and our volume will be equal to 1/3 times B, which is 45, times H is 14. Okay, make sure you can enter this into your calculator correctly. Okay, so if you haven't tried, make sure you can do that. You should get 210. I got 210. Yeah? Okay, so I got 210 feet cubed. Okay, questions on number 2? All right, so then number 3, at the top of the Washington Monument in Washington, D.C. is a small square pyramid. Okay, so this very top part here. Okay, it's called a pyramidion. This pyramid has a height, of 55.5 feet with base edges of about 34.5 feet. Okay, so what is the volume of this pyramidion? Okay, and we're going to round to the nearest tenth. So thinking about this, it's a square pyramid. That means your base is going to be a square. Okay, so our base is a square. Right? Now if it says the base edges are about 34.5 feet, that means each of these edges around that square base are going to be 34.5 feet. Okay, so since this is my base, I can use that information to find capital B. Okay, so to find capital B, we're finding the area of that base. So I'm going to multiply 34.5 times 34.5. Okay, and that is 1,190. And I'm just going to write 0.25. Okay, so our base area is 1,190.25, and that is in feet squared. Now, what's the height of this pyramid? Okay, it did give us the height already in our problem. It was 55.5 feet. Okay, so now that I have B and H, I can find the volume of this pyramid. So we'll have 1/3 times our base, or capital B value, times our height. Oops. There we go. Okay, so multiply these two values together and divide by 3 to get your volume. Okay, and I got this volume to be about 22,019.6. And that will be in feet cubed. Okay, so again, we're still finding this capital B value and this H value in order to find the volume. Now, since it's a pyramid, your volume formula is a little bit different. You have that 1/3 piece, okay, because we do only have one base in a pyramid, okay, whereas when we were finding the volume of a prism and a cylinder, you had those two bases. So this pyramid is actually cut from a prism. Okay, so it's part of a prism if you were to extend those sides to make it a prism. That's where that 1/3 piece comes in. Okay, any questions on my volume of a pyramid examples here? All right, don't worry about the one on the back.
Oh, okay.
That's for tomorrow. I don't know how it did that. Don't worry about the one on the back.